On July 26, 2019, astronomers found an asteroid. When they traced its path backward and calculated where it had been the day before, the room went quiet. A rock the size of a 40-story building had passed closer to Earth than the satellites running the world's GPS systems. Closer than the moon. Close enough that a difference of a few hours could have erased a city. And nobody had seen it coming. The asteroid was designated 2019 OK. By the time the detection was confirmed, it was already leaving, already safe, receding into the dark. When scientists calculated the actual distance, they kept returning to the same number, 65,000 kilometers. The moon sits at 384,000 kilometers from Earth. This rock had passed 6 times closer than the moon, threading the gap between our planet and our own satellite network. And the first confirmation arrived after it had already gone. A city killer. Multiple detection systems on Earth, and it slipped past all of them. At somewhere between 57 and 130 meters wide, 2019 OK sits in a dangerous middle category. Too small to activate the global tracking systems reserved for civilization-ending threats. Large enough to eliminate everything beneath it. History has already documented what an asteroid this size can do. In 1908, an object roughly the same diameter detonated over Tunguska, Siberia. It never reached the ground. It exploded in the upper atmosphere, and the force of that single detonation flattened 2,000 square kilometers of forest. Every tree for dozens of kilometers was knocked horizontal, pointing outward from a single point in the sky above them. Tunguska happened over empty wilderness. That detail is the only reason there were no casualties. 2019 OK carried the same destructive potential. An energy release equivalent to roughly 30 Hiroshima bombs, concentrated into a single moment, onto whatever patch of Earth happened to be beneath the impact point. And here is where the numbers become genuinely unsettling. 2019 OK wasn't aimed at Earth. It passed through a corridor of space between our planet and our satellites. Whether it would have struck, and where, came down entirely to planetary rotation. Earth completes one full rotation every 24 hours. A few hours earlier in that cycle would have placed South America beneath the impact point. A few hours later, Sub-Saharan Africa, Western Europe, or the open Atlantic, which carries its own category of threat. An ocean impact generates tsunamis that propagate outward toward every coastline within range. The difference between a footnote in an astronomical database and a mass casualty event came down to a few hours of rotation that nobody was monitoring. Because nobody knew there was anything to monitor. 2019 OK approached from the direction of the sun. This is the same blind spot that allowed the Chelyabinsk asteroid to reach Russia without warning in 2013, injuring over 1,500 people before a single alert could be issued. The reason isn't negligence, it's physics. The sun produces light intense enough to overwhelm every optical sensor built for deep space observation. Point a telescope toward it, and the image doesn't degrade. It erases. The entire field becomes white. No detail, no depth, no warning. Any object moving toward Earth from inside that glare is invisible by definition. It can only be detected after it has crossed the sun's position relative to Earth and entered the dark portion of the sky, where our instruments can actually function. 2019 OK didn't outmaneuver our detection systems. It simply arrived from the one direction where detection is physically impossible. The uncomfortable part isn't that this happened once. It's that everything that allowed it to happen remains exactly the same. NASA is developing Surveyor, a space-based observatory designed specifically to watch the sunward blind spot and detect incoming objects before they cross into detection range. it has not launched. The gap in planetary coverage today is identical to the gap that existed on July 26, 2019, and the gap is wider than most estimates account for. Asteroids in the 50 to 150 meter range number in the tens of thousands, possibly hundreds of thousands. Current catalogs cover less than 10% of them. The rest are out there now, undesignated, untracked, following orbital paths no instrument has yet plotted. Some will be found months before they pass. Some will be found days before. And some, like 2019 OK, will only be confirmed after they have already gone. The designation 2019 OK sounds like confirmation, like the universe filing a report that everything turned out fine. And it did. But not because of preparation, detection, or because any system performed the way it was built to perform. It passed us because of timing. Earth's rotation placed nothing critical beneath the impact point at the exact moment it arrived. That was the margin. Hours, rotation, and luck. But luck isn't a detection strategy. Somewhere in the current catalogs, and in the far larger number of objects that don't appear in any catalog yet, there are asteroids following paths we haven't calculated. Most will never intersect with Earth's orbit. Some will pass too far to register, and some will be large enough to matter, approaching from directions the current infrastructure cannot observe, arriving in windows too short for any organized response, even if detection had somehow occurred on schedule. The question isn't whether another 2019 OK is possible, it's whether we'll see it before it arrives. If this changed how much warning you think we'd actually have, subscribe. There are more close calls we barely know about. See you in the next one.